In this lesson, we are going to go over solving rational equations with many variables. So I have a bunch of different letters listed up at the top. What we'll do is we'll apply our understanding of solving rational equations to solving rational equations with many variables. So just like when we did this previously, when we solve for a variable, it's going to be in terms of another variable. So we're not going to get a number, we're going to get whatever variable we're solving for equals, and then some combination of other variables on the other side. So let's look at a few examples. For some of these, I will be going over more than one way to approach the problem. So feel free to choose what works best for you. Example 1, solve for m. So we're solving for m. Whenever we have denominators, they're typically in our way. We usually want to get rid of them. In this case, there's two ways to do that. The first way is, since k is the only thing in the denominator, on the right-hand side, if I multiply the right-hand side by k, the multiplication by k and division by k will cancel. And if I multiply by k on one side, I have to multiply by k on the other side. So I would have kh is equal to mn. The other way to approach the denominator of this problem is, notice we almost have a fraction equals to another fraction. If I put a 1 under the h, now I have a fraction equal to another fraction, and I can cross multiply. So I have hk, which is the same as kh. Remember, in multiplication, it can be 2 times 3 or 3 times 2, equals 1 times m times n, so we get to the same place. Okay, so I'm only going to solve the one on the left, but we got to the same spot with those couple of different approaches. Now we're being asked to solve for m, so the only thing in our way is this n. When two letters are next to each other like this, it means multiplication. So this is m times n. So in order to move the n, we need to divide, because multiplication and division, this would cancel out to be 1. So if I divide one side by n, I divide the other by n, and I get m is equal to kh over n. Okay, so this would be my final answer. Next, I have solve for y, so I have m is equal to g over a plus y. So similar idea here, you could either multiply both sides by that denominator or use proportions. But one thing to be careful of is we're multiplying by a plus y. So when we multiply by a plus y, put it in parentheses, or remember that the m will distribute to the a and the y. So now we have m times a plus y is equal to g. Okay, from here, there are also two different approaches. Okay, so I'll start with one. One approach is to divide both sides by m. Okay, and the reason being is that the y is inside the parentheses, it's being multiplied by m, so we can take and divide both sides by m to get a plus y, because my m's cancel, is equal to g over m. Okay, now the a is in our way and it's being added, so we subtract it from both sides to get y is equal to g over m minus a. So this is one way to do this problem. Okay, when you're subtracting a, it's a term on its own. The other way, and I'm going to start from m a plus y is equal to g. You can distribute the m to make sure that we clear the parentheses. So we have ma plus my is equal to g. Again, we're still trying to solve for y. The first term that's in our way is this ma. So we subtract it from both sides. Positive ma minus ma cancels. We're left with my is equal to g minus ma. Okay. Again, m times y multiplication, we're going to divide both sides. So we get y is equal to g over m minus, g minus ma over m. Now here the m's don't cancel, okay, because there's not an m in front of g. But you could split this up as g over m minus ma over m, and then the m's would cancel, and it looks like the same exact answer we just got. Okay, but either of these are okay. Next, example 3, solve for a. So in this case, we have a square root and a denominator. We need to get our denominator out of that square root first. So in order to do that, we'll square both sides. So on the left-hand side, we'll have b squared, and this is equal to the squared and the square root. Cross off, 7 divided by c times a. And now we have a denominator. I'll do this one with proportions just because I didn't do the last one with proportions. So I'll put the b squared over 1. So we cross one way, so this is b squared times ca is equal to, and then we cross and go the other way, 1 times 7. So we have b squared ca is equal to 7. and we're solving for a. So the things that are in our way, remember that this is all multiplication here. So you can divide by b squared times c, because that would allow us to cancel b squared and c. Okay. So my final answer here then is a is equal to 7 over b squared times c, or if you prefer, 7 over c b squared. Okay, those are the same. Next example, solve for s. So 1 over s plus 1 over r equals 1 over p. So in this case, we can use what we learned with the least common denominator, where we find our least common denominator, make sure all of our fractions have that, let go of the denominator, and see how to solve for s. So in this case, our least common denominator is s times r times p, okay, because we'll have to multiply them all together in this case to get the least common denominator. So this first fraction needs r times p, so I multiplied by r times p on the top and bottom. The second fraction, the denominator needs s times p, so I do that in the numerator. And then the third fraction needs s times r. Okay, so now I have rp over rp times s plus s times p over rps. So they all have the same denominator. You could technically multiply both sides by that. So we have rp plus sp equals sr. Now in order to solve for s, we need to get our s's together and whatever is not part of our s to the other side. So I'm going to subtract sp from both sides. So on the left-hand side, I still have rp. Sp minus sp cancels. Bring down our equal sign, and we have sr minus sp. And it just stays that way because they don't combine. They're not like terms, even though they both have s's. Okay? So notice on the right-hand side, both terms have an s in them, which means that s is the greatest common factor, and I can factor it out. So I have rp is equal to s times r minus p. Okay, this is multiplication, so remember we can divide both sides by r minus p. So we have rp over r minus p is equal to s. And this is our final answer. The last example that we'll do, we're solving for capital P. Okay, so there are multiple variables here, and the capitalization and the lowercase do matter. Capital P is probably going to have a different value than lowercase p. Okay, so when you're solving, just be particular or be specific, follow the directions of the problem. So this case, we have a fraction equals to another fraction, so I'm going to cross multiply. This is PV times little t equals lowercase times capital T. Okay, so now what I have if I simplify is I just have PV little t is equal to PV capital T. So don't lose track of your letters here. We're solving for capital P. The v times t is in our way, so we can divide both sides by v times t to get capital P is equal to lowercase p, lowercase v, capital T over capital V, lowercase t. And that would be our final answer. Thank you for watching. If you have any questions, feel free to reach out to me.